The media command in the ASAP Script Editor now accepts direct input of Sellmeier, Herzberger, Conrady, and Schott coefficients. To demonstrate this enhanced capability, we'll define a Sellmeier dispersion formula for the common high-index glass LASF 45. We've used variables to define a number of visible wavelengths in our wavelengths command, and under the media command, we note the direct use of the Sellmeier keyword as well as the wavelengths defining the range over which the dispersion formula is valid. We can then enter pairs of coefficients for the given material. If we look at help under the media command, we'll see that the equations are listed for each of the dispersion formulas now supported. Note that all coefficients must be defined even if there's zero. We'll now run this file, plotting the real index values calculated from the Sellmeier formula, and see the results from our high-index flint glass. We can view the results in more practical terms by constructing a prism and demonstrating the relative dispersion of the visible wavelengths that we previously defined. In a second example, we construct a Herzberger formula for the infrared material germanium. We see the use of the Herzberger keyword under the media command and the required coefficients. Here, we construct a lens and again show the relative dispersion for a number of wavelengths across the mid-infrared. Most references provide dispersion formulas for materials, and with this expanded command flexibility, ASAP users now have a number of options for defining material index of refraction over a specified wavelength range.